The Infrared Polarization of the Infrared Star in Cygnus by Fred Forbes, Lunar and Planetary Laboratory, University of Arizona. In an effort to obtain far infrared data on the wavelength dependence of polarization, we have developed a new infrared polarimeter at the Lunar and Planetary Laboratory, thereby extending our polarization measurement capability to 3.4 microns. Of the two extremely red stars reported by Neugebauer, Martin, and Layton in 1965, the one in Cygnus was discovered to be significantly polarized at 1.62 and 2.2 microns, while the polarization of the Taurus object is indistinguishable at 1.25, 1.62, and 2.2 microns from that of 7 standard unpolarized stars. We also detected a sharp decrease in the polarization of the Cygnus objects from 2.2 to 3.4 microns. These observations were made in November-December 1966. The experimental apparatus consisted of a liquid nitrogen-cooled lead sulfide photopolarimeter attached to the Catalina Observatory 60-inch infrared telescope. Johnson and Mitchell, 1962, have described a photometer similar to the photometer part of the photopolarimeter. The Polaroid Corporation Type HR sheet polarizer was used for the 1.25, 1.62, and 2.2 micron measurements. It was placed between the space chopping mirror and the lead sulfide cell, thereby gaining the advantage of space chopping as well as maintaining constant positioning through the HR analyzer. The analyzer was rotated at 0.67 cycles per second, producing an AC signal whose amplitude is proportional to the degree of polarization of an observed object, in a manner similar to the Hall polarimeter. The individual observations for each night on which the NML Cygnus object was measured are presented in Figure 1 in Table 1. Phase angle measurements are in the equatorial frame of reference. The uncertainty in the Cygnus object's phase, measured at 1.62 and 2.2 microns, is plus or minus 3 degrees. The instrumental polarization uncertainty is denoted in the figure by the error bars. The instrumental polarization is 2.35% at 3.4 microns and 1.5% at 1.25, 1.62, and 2.2 microns. The polarization of the NML Taurus object does not differ significantly from the instrumental polarization. In conclusion, it is evident that the polarization characteristics of the NML Taurus and Cygnus objects are greatly different, even though their colors are similar. Since the Cygnus object is the only object observed that is significantly polarized in these infrared wavelengths, and since it is located in Cygnus in a region of high interstellar reddening, we conclude that its polarization is probably due to the interstellar material in this region. The sharp decrease in polarization of the Cygnus object beginning at 2.2 microns could be explained by the presence in the interstellar medium of aligned particles which have dimensions approximately 5 by 0.3 microns. This model would show strong polarization in the shorter wavelengths, with a weaker polarization shifted in phase by 90 degrees in the longer wavelengths. The high visual polarization of 6 Cygnus number 12, which is near in the sky to the NML Cygnus object, indicates that a strong magnetic field is present and suggests that the source of both polarizations is due to an interstellar cloud, the Great Rift in Cygnus. This work was supported by the National Aeronautics and Space Administration and the National Science Foundation.
Astrophysics, Venet Bernar, 1968, New York.